Hi everybody. First of all, I would like to introduce myself. My name is Raúl Germán Bautista Margulis, and I will be the speaker to this presentation entitled Climate Change, Environmental Implications and Mitigation Strategies. Nowadays, the mother of all environmental issues facing our planet is certainly the climate change. By definition, it is the variability of the atmospheric conditions that our planet undergoes throughout the time, that is, for years, decades, centuries, or millions of years. Such change comprises three main aspects worldwide: mitigation, vulnerability, and adaptation. From these aspects, we will focus only on mitigation, considering the key problems for environmental pollution, greenhouse effect, global warming, and reduction and control of carbon emissions in the short, middle, and long term. The reduction of environmental pollution has been a primary target from governmental institutions, private enterprises, research centers, and universities around the world. There are two types of emissions: anthropogenic and biogenic. Anthropogenic emissions come from human activities and can be divided by stationary and non-stationary sources. Power plants and industries are the best examples for stationary sources, while those in the transport sector, like vehicles and airplanes, belong to non-stationary sources. In the case of biogenic emissions, it is generated by the nature itself, that is, volcanic eruptions, fires in the forest, electric storms, etc. Regarding environmental pollution, we usually find 3 to 5 impact scales according to the literature. To my personal view, we can describe it at 3 different levels, such as global, regional, and local scale. As illustrated in this slide, several examples are shown for each scale, understanding that a given environmental impact may scale up to the next level. In this case, a perfect example would be the oil spills. In the early 80s, the United Kingdom, particularly England, estimated that Earth contained about 500,000 millions of air tons, reason by which they had an aphorism saying, "The solution of pollution is dilution." In the middle of the 90s, however, investigations undertook by the MIT in the United States revealed a hole in the upper ozone layer, meaning that the atmospheric air was not enough to dilute the increasingly carbon emissions. At this point, it is worth mentioning that Dr. Mario Molina was granted with the Nobel Prize for such scientific findings. Fossil fuels can be found in just about every aspect of our modern life, including the cars we drive, the electricity used to power the grid, and the energy used to heat our homes. The burning of fossil fuels like oil, coal, and gas contribute to 75% of the total global greenhouse emissions and 90% of the total global carbon dioxide emissions. In this slide, three industrial flames can be observed within a power generation plant. In this context, it is very important to take into account the design and operation of high-efficiency combustion burners in order to reduce the formation of particulate and gas pollutants, complying with the maximum permissible emission levels established in the environmental legislation. The Earth's atmosphere is a gaseous bag of approximately 200 kilometers width, which protects the human beings from the harmful effects of the ultraviolet solar radiation. Generally speaking, solar rays land on Earth with an intensity of 1300 watts per square meter. Hence, 30% is reflected by the upper layers of the atmosphere and clouds, 19% is absorbed by the air itself, and 51% get to the surface. From this energy on the surface, solar radiation splits on 51% as infrared, 40% visible, and 19% ultraviolet. Nevertheless, the ground surface and sea send infrared radiation back to the sky where it is absorbed by the air again or bounced back to the surface, while the rest escapes to the outer space. When infrared radiation gets back to the Earth, there is also an increase of such radiation due to certain gas concentrations, namely carbon dioxide, methane, chlorofluorocarbons, nitrogen oxide, and water vapor mainly. Therefore, these gases in excess will be bouncing back more infrared radiation to the surface, producing the so-called greenhouse effect. People say that a picture worth more than 1,000 words. Global warming is the increase of the average surface temperature in our planet as a consequence of the greenhouse effect. The positive side of these gases, when moderated, keep an average temperature of 15 degrees centigrade in the ambient. Otherwise, without their existence, the average temperature would be minus 18 degrees centigrade. Let's remind the Protocol of Tokyo, adopted in December 1997, which did not come into force until February 2005. Such protocol expired in 2012, bearing in mind the reduction of greenhouse effect gases in 5% with respect to the 1990 levels. In November 2009, 187 countries approved the protocol. In 2011, the United States refused to sign the protocol and Canada abandoned it. Unbelievable why a nation like the United States, with less than 5% of the world population, did not comply with the protocol, since they used to produce alone up to 25% of the carbon emissions. In 2020, the statistics show that 52.4% of the greenhouse effect gases resulted from only three sectors in the following order of importance: electric power generation, industrial processes, and gasoline-based vehicles. With respect to the origin of the greenhouse effect gases, the main contributor for carbon dioxide is the power generation plants, with 29.5%. For methane and nitrogen oxide is the agriculture, with 40% and 62% respectively. At the 2023 United Nations Climate Conference, better known as COP28 in Dubai, 130 countries pledged to triple the world's renewable energy capacity and to double the annual rate of energy efficiency improvements by 2030, in a push to limit global warming to 1.5 degrees centigrade. The annual increase of CO2 concentration in the atmosphere has jumped from 300 parts per million in 1950 to 360 parts per million in 2004. In 2013, sensors of NASA and the Scripps Institution of Oceanography from the University of San Diego recorded the highest CO2 concentration level in the atmosphere, surpassing the 400 parts per million. This concentration level had not been seen since 3 or 5 million years ago in the Pliocene. In 2024, this concentration dramatically increased up to 425 parts per million in the atmosphere. To the current pace of pollution, the CO2 emissions will be double in 2056. Even if constant measures were taken, the gas concentration in the atmosphere would be higher than 560 parts per million, doubling the pre-industrial number. In the last 50 years of the 20th century, the increase in average temperature doubled that in the 19th century. At this point, the global average temperature raised 0.74 degrees centigrade by the year 2000. In 2023, the Earth's average surface temperature has been reported around 1.2 degrees centigrade higher than in the pre-industrial era. The numbers projected in 2007 from climatic models have been registered in the Fourth International Panel for Climate Change. In this report was indicated that the global temperature would be increasing during the 21st century. In the lower emission scenario, the increase would be between 1.1 and 2.9 degrees centigrade, while the highest emission would be expected between 2.4 and 6.4 degrees centigrade. Bearing in mind these various model results, if the increase of global average temperature is higher than 4 degrees centigrade, the natural systems will not be able to adapt. Therefore, the surrounding populations cannot be sustained anymore. In other words, there will be no natural resources to sustain human life. Although these studies focus on the year 2100, the warming is expected to continue for more than 1,000 years, no matter whether the greenhouse gases stabilize. It is estimated that half of the human population live in or near the offshore, and there is also a tendency to move from the continental regions to the coast. The increasing pressures on littorals around the world will continue affecting not only the coastal ecosystems, but also will impact hotel constructions, touristic centers, housing, and, of course, population, causing an economic significant loss in the region. Some historical examples of natural disasters were Hurricane Andrew in Florida, 1992, with losses for $25,000 million. Hurricane Vilma in Quintana Roo in 2005, with losses for $20,000 million. Hurricane Katrina in New Orleans, 2005 also, with losses for up to $100,000 million. And most recently, Hurricane Otis in Acapulco in 2022, with losses of $50,000 million approximately. In the case of tornadoes, the biggest ever was presented in Oklahoma, May 2013, with 2.5 kilometers wide in the base of the tornado itself. On the other hand, high spatial resolution simulations have indicated from future projections up to 2090 there will be less hurricane events in the Gulf of Mexico and the North Atlantic. However, the intensity of the hurricanes will be increased in these zones. In this slide, two cases of climate change are presented. Pictures of the Sunset Glacier in Alaska are depicted in two different years, 1939 and 2004. After 65 years, the ice in the mountains practically disappeared. Likewise, pictures of the Uppsala Glacier in Argentina are depicted in two periods of time, 1928 and 2004. Once again, after 76 years, the glacier turned literally into a lake. The evolution of carbon global emissions is presented to the 2000 year. Historically, the carbon emitted from solid and liquid fuels are higher than those for gas fuels. At that time, the total carbon emissions were about 7,000 million tons in a year. In 2022, it was estimated that such carbon emissions doubled the amount up to 13,267 million tons per year. For CO2 global emissions, the international statistics also showed a constant increase of 25,000 million tons, 34,000 million tons, and 37,000 million tons in 2000, 2011, and 2022, respectively. Therefore, the increased range between 2000 and 2022 indicates 32% more CO2 emissions in almost a quarter of the 21st century. A positive figure in a given year indicates that emissions were higher than the previous year. A negative figure indicates they were lower than the year before. For example, a change of 1.5% indicates that global emissions were 1.5% higher than the previous year. Likewise, minus 1.5% would mean they were 1.5% lower. This measure allows us to see, firstly, where emissions are rising and where they are falling, and secondly, the rate at which emissions are changing, whether the growth in emissions is slowing down or accelerating. China, the United States, India, Europe, Russia, and Brazil were the world's largest greenhouse gas emitters in 2023. Together, they accounted for 49.8% of global population, 63.2% of global gross domestic product, 64.2% of global fossil fuel consumption, and 62.7% of global greenhouse gases emissions. Under the 2015 Paris Agreement, countries pledged to keep global warming below 2 degrees centigrade, with the ambition of limiting it to 1.5 degrees Celsius. Years of international climate action have put the world on the right path. Projected global warming is much lower than it was a decade ago, but the pace is still far too slow. A growing chorus of scientists has warned the 1.5 target may now be dead, but that doesn't mean there is less urgency. Every fraction of a degree makes a very big difference in impacts on the ground. The difference between 1.5 and 2 degrees means hundreds of millions more lives will be at risk from extreme weather events. And for some ecosystems, it's a death sentence. For coral reefs, if the difference between wiping them off the face of the earth and managing to hang on to some of them. Two remarkable investigators named Sokolov and Bacala in 2004 from Princeton University proposed two long-term plans. Firstly, a stabilization plan during 50 years, from 2006 to 2056, based on 7 wedges, each wedge representing a reduction of 25,000 tons of CO2 emissions. Secondly, a true reduction plan for the other 50 years applying future and innovative technologies. In order to cover the 7 wedges, several techniques can be combined separately or in parallel time, as shown in the next slide. The following techniques were recommended for the stabilization plan, such as conservation and performance in the final use, energy generation, carbon capture and storage, agriculture and silviculture, and renewable energies. In this context, several projects can also be developed for each technique used. For instance, a vehicle rolling down 16,000 kilometers per year and consuming 8 liters per each 100 kilometers, it will annually emit about 1 ton of carbon. The experts in transport predict that there will be circulating 2,000 million vehicles by 2056, moving each up to 16,000 kilometers per year. With a similar fuel consumption, it would release 2,000 million tons of carbon a year. Meanwhile, if the performance doubled, only 4 liters per 100 kilometers would be consumed, and then, therefore, an emission of 1,000 million tons of carbon will be avoided. Another good example is that for energy generation. If the nuclear reactors would triplicate in the world, 1 or 2,000 million tons of carbon would be saved. This means to reach 1 terawatt of nuclear energy towards 2050, installing about 2,000 megawatts per month. That is 2 big power plants investing $2 billion during various decades. However, nuclear energy has an environmental disadvantage due to the final disposal of the radioactive wastes. A comparison in time between renewable and non-renewable energies is shown in this slide. From 2000 to 2019, it can be clearly seen how fossil fuel consumption has been reduced 7.3%, while renewable energies increased 13.4% in the same period of time. Regarding solar energy, the panels have semiconductor materials to convert solar energy into electric energy. Solar panels are made up of different materials, from polycrystalline silicon to silicon thin film cells, and devices composed of either organic or plastic semiconductors. The energy transition has had the most dramatic impact on the global electricity system. Wind and solar generation has grown from a combined 774 terawatts per hour in 2013 to nearly 4,000 terawatts per hour in 2023, more than quintupling in a decade. Together, wind and solar accounted for 13% of global electricity supplies in 2023, up from 3% a decade earlier. Still, rapidly rising demand for electricity, which is expected to accelerate as heat, transport, and industry are increasingly electrified. The biofuel sector is mainly produced by biodiesel and bioethanol. Biodiesel is obtained from vegetable oils coming from oilseed plants. Bioethanol, on the other hand, is fermented by sugar extracted from sugarcane, corn, wheat, barley, etc. Bioethanol is used by mixing it with gasoline in low percentage, usually 5 to 10%. The mix taken to 10% is called gasol. In the case of vehicles with flexible fuel, mixing of 85% ethanol and 15% gasoline are employed. Brazil is the major producer and customer of bioethanol in the world. This slide presents some of the future technologies for the reduction plan in the period 2056-2116. Fusion reactors that generate energy by the union of atomic cores may exert the same thermonuclear force as the sun burning energy. Gigantic electromagnets are used to contain the ionized fuel within a chamber where the plasma heats up to more than 100 million of degrees centigrade. The first project was the International Thermonuclear Experimental Reactor, located in France. The objective was to demonstrate its capacity to control the fusion in helium of two isotopes from hydrogen, deuterium, tritium. The aero generators could bring up to 50 megawatts of power energy. Various tests would have to take into practice at high altitude in order to observe whether they resist turbulence, variable flow intensity, and electric storms. High costs of maintenance may be an issue for its implementation. In a geostationary orbit, far away from the shadow and the Earth's atmosphere, the average solar light intensity is 8 times that from the surface of the Earth. Nevertheless, the ratio between power generation and orbit mass is still being too low, reason by which is not very attractive to be financed yet. Japan, through its spatial agency, has launched a prototype to generate 250 megawatts. In the case of the most perfect and costly solar cells made up of silicon, they reach a maximum performance of 22%. New materials with quantic points would duplicate that value. That is, when solar light incises in a silicon cell, a photon may take away an electron. In this sense, quantic points allow to take away 7 electrons per photon, raising its performance of captured energy. Concerning genetic engineering, it pretends to replace the petrochemical industry. For example, microorganisms are used to capture CO2 in the chimney of a power plant and either be converted to natural gas in industrial boilers or convert up to 40% of CO2 in biofuels like ethanol. Likewise, biological systems can be constructed to produce hydrogen owing to the solar light via photosynthesis. Other selected topics may be taken into consideration, even though sounds like science fiction and can be browsed as number 1, cold fusion, number 2, matter and antimatter reactors, and number 3, tachyonic energy. We can conclude that the problematic of climate change gets worse due to an indiscriminated fossil fuel consumption. Therefore, it is of paramount importance to gradually reduce and substitute them. To avoid jumping from a greenhouse effect to woven represents the most important scientific and technological challenge for mankind. It is also imperative to radically restructure the global economy of energy. In this slide, we can watch this poor polar bear hanging on a piece of ice, but we we have to make a question to ourselves. Do we have the capacity and will to reverse the process of climate change in time? Thanks very much for your attention. I really appreciate your assistance and have a nice day to all of you. Bye bye.